Hello everybody and welcome to the first Lunabotics mechanical team update of the spring semester. My name is Dan Gower. The other team members are Kaylee Robertson, Perry Orthy, and James Sweeson. We were very busy during the winter break, including the first test of our first prototype. We were able to thoroughly test out the drive system we had designed, which was a two-wheel drive. As you can see in this video here, we actually had a lot more trouble with it than we had really anticipated, so this sparked a lot of redesigning and rebuilding during the break as well. We wanted to stick with the similar frame design, but we needed to update it a little bit. The frame we were using was not conducive to the type of robot that we wanted to have, so we redesigned it, making two very clean triangular shapes, one for the collection and one for the dump, as you can see in our 3D image here. We wanted to stick with the same two-motor drive system though, to avoid adding extra weight to our robot. However, the gears that we were using needed to be redesigned, so what we did was we redesigned the gears into a 1.16 to 5 ratio. This will allow us to have a little bit more force to enable us to use a four-wheel drive system. The first thing we needed to take into account when we decided to design the four-wheel drive system was how many bearings would support each shaft. The previous frame we were using only used one roller bearing and one slip bearing. As we saw in our prototype test, the slip bearing actually fell out on two of the axles. So what we did was we redesigned the system so that there are two roller bearings for each drive shaft. We needed to decide how we would transfer power from the rear axle to the front axle. We opted to use a chain sprocket and chain system, as this allows us to use a keyed sprocket to ensure the proper transmission of power, along with a chain which doesn't slip nearly as much as, say, a gear train might over this long of a distance. We made a number of updates to the collection system as well. Most notably, to save on weight, we decided to use an idler sprocket connected to the frame via flange, instead of using a roller bearing and shaft, as this cuts out almost a half a kilogram of weight on each individual sprocket for a total savings of close to 2 kilograms of weight. One of the problems we encountered with the dump system was that by using a motor directly attached to the main drive shaft of the main pulley of the conveyor belt, we actually exceeded our overall width allowance, and it made for a very tricky connecting of the motor to the frame. The way we fixed this was by using angled gears, which allowed us to put the motor very close to the frame, making it much easier to attach, and also solving our overall width problem. After a little bit of thought and design in SOLIDWORKS, we decided to keep the electrical box where it was on the rear of the robot. This is for a few reasons. First of all, it gives a little bit more weight directly above the rear axle, providing us with a little bit more traction. It also makes it much easier for the electrical engineers to go and access their components for servicing and maintenance when needed. We then had to decide where we were going to place the battery. We initially had it directly behind the electrical box, right over the rear axle. As we noticed, if you have too much weight over the rear axle, the robot actually sinks into the material. So to fix this, what we did was we were going to put the battery directly in between the frame rails, in between the front and rear wheels. This will allow an equal distribution of weight over the rear axle and also put a little bit of weight onto the front axle, which should help even out the robot as it traverses the Lunabotic arena. The next steps from here are to go and order all of the materials, which we've actually done earlier this week. We plan to begin fabrication early next week and have an estimated completion date of March 1st. Over spring break, we intend to perform a fully autonomous test of both the collection, dump, and drive system. After that, we will go back into a redesign phase and see what went right and what went wrong. Thank you so much for watching. My name is Dan Gower, and this has been the Lunabotics video.